Another geometric relationship between lines that we want to talk about in terms of the coordinate plane is lines being perpendicular. If lines are not parallel, they meet somewhere, and if they meet at a right angle, they're called perpendicular lines. When we look at the slopes of perpendicular lines, we see that they are opposite reciprocals. So we both reverse the sign and we take the reciprocal to find the slope of a perpendicular line. To see how that works, let's take a look at an example. Here we are given a line, y equals 3/4 x plus 2. This line has a slope of 3/4. This is a positive number, so the slope of a perpendicular line will be negative. And then we take the reciprocal of 3/4 to get 4/3. The slope of the given line is 3/4, so the slope of a perpendicular line is negative 4/3. We want our line to go through the point 6, -3. So in point slope form, our line has the equation y minus -3 equals -4/3 times x minus 6. And we'll rewrite minus -3 as plus 3. But unless our goal is to have this in some particular form, we don't need to do anything else to it. We don't need to multiply it out, nothing like that. Now, if our lines are horizontal or vertical, again, the perpendicular line is easier. If the line is horizontal, perpendicular lines are vertical. If the line is vertical, perpendicular lines are horizontal. So if we want to give a line perpendicular to the graph of y equals 3, well, y equals 3, y equals a number is a horizontal line, which means a line perpendicular to that will be vertical. Vertical lines are in the form x equals a number. So we want to go through 5, -2. We need to have x coordinate 5. The line we want must be x equals 5. Okay, and then the last question is, what do we do if we're given an equation in standard form and we want to find the equation of a perpendicular line? Here we have the equation 3x minus 5y equals 10. We want to get the equation of a line perpendicular to this, passing through this point. The standard method here is to rewrite in slope-intercept form, look at the slope, and then use the slope to write a perpendicular line. So we'll solve for y. First we'll subtract 3x from both sides, and then we'll divide both sides by -5. So here's the slope-intercept form. Our given slope is 3/5. So our new slope, switch the sign so it's negative, take the reciprocal. Our new slope will be -5/3. Putting that into the point slope form with the given point, we'll have y minus 1 equals -5/3. X minus -2 is x plus 2. Okay. Let's see what this looks like, though, if we put it into standard form again. First, we'll distribute. We'll collect all the variable terms on the left, all the terms without variables on the right, and then we need to multiply both sides by something to get rid of these fractions and make sure that this first coefficient is positive. It looks like 3 will work for that. So we'll be left with 5x plus 3y equals -7. Okay, so now let's look at the equation that we found here compared to the original equation that we were given. On the left-hand side, we see the same coefficients, just in the opposite order, and the negative 5y became a positive 5y. So we swapped the coefficients, and then we made the negative 5 positive. In general, we'll change one of the signs, whichever sign we have to change to leave x positive. How could we come up with the negative 7? Well, we want to have 5 times negative 2 plus 3 times 1 be solutions. That works out to negative 7. So to find the constant that it's equal to, plug in the point that you want to have work, and that'll tell you what constant we need to be equal to. Now, just like the case with parallel lines, you will get absolutely the right result if you go through the process of finding the slope, writing the point-slope form, and then turning it into standard form. Or in many cases, you can just leave the point-slope form, unless you're asked specifically for something else. However, this does provide a nice shortcut as far as finding perpendicular lines goes.